Very good morning to all of you. Today I want to take session 8 of module 1. Title of the module 1 is Subsurface Explorations and course outcome is Ability to plan and execute geotechnical site investigation program for different civil engineering projects. Subject title is Applied Geotechnical Engineering and the subject code is 18CV62 in 6 semesters of civil engineering departments. Contents. Today's contents are well point system, deep well system, shallow well system, electro osmosis method and conclusions based on above dewatering methods. Okay, so these are the contents are required to explain in detail in session 8. So here well point system, deep well system, shallow well systems diagrams are given here to know the lowering of groundwater level by installation of deep well systems. Of this diagram is explained. See here, these are the two collector pipes and these are the excavations. So this is excavations, this is original groundwater level, and this fourth is deep well, and these are fifths are two collector pipes, and the sixth one means these dotted lines is explained as a drawdown curve after pumping, and this one is pervious layers below the ground level. This is pervious layer, and next one is impervious layers. Okay, this is seventh one is pervious and eighth one is impervious layers. Okay, and these two diagrams are explains for lowering of ground water level with well points, figure A and B, detail of drive point and screen of a well point, and connection well points with header pipes. And this figure C is multi-stage well point systems. So these are the multi-stage well point system installation for lowering of water levels to great depth. So based on these diagrams, explanations are explained here. When construction operations have to be executed below the groundwater level, it is desirable to temporarily lower the water tables such that work can proceed in relatively dry conditions. Dewatering of soil can be done by the following methods based on these deep wells, well point systems, and multi-stage well point installation systems. The arrangement for sumps and pumping is explained, and as well as here based on the above figure, by the use of sumps and pumps, the working area can be kept totally dry since water seeps down the slope continuously. Above methods are based on the fact that removal of water by continuous pumping from a well causes the water table's level to become depressed and result in the formation of a drawdown curve. See, this is the drawdown curves. Okay. When a series of wells are placed close to each other, the overall effect is lowering of the water table level as shown in the above figures. Okay. The arrangement of deep wells and well points for lowering of water table is explained in the above figures. A comparison between deep wells and well points is made. Deep wells have larger diameter, more depth and greater spacing in comparison to well points. Well points, being smaller, are easy to install, whereas deep wells have to be drilled akin to be tube wells. Well points can lower the water tables by only 6 to 7 meter because the pump, which is located at the ground surface and connected to a stage well points, are used based on the above figures. However, deep wells become more economical if more than 3 to 4 stages of well points are required. That's called multi-well point systems. In deep wells, the pump is located at the bottom of the well and hence they pump out water from greater depths than well points. Okay, so now I want to compare between well points and deep wells. Diameter in mm, so that is in well points 50 to 8 mm and deep wells 150 to 600 mm is given, and depth in meters, in well points up to 7 meters but in deep wells 50 or more than 50 meters. Spacing between wells in meter, for well points 1 to 4 meter, deep wells 5 to 50 meters. Pump, for well points, one pump for a group of well points, pump located at the top and connected to well points through a header pipes. In deep wells, one pump in each well located at the bottom of the wells. Depth in meter to which groundwater level can be lowered. For well points 15 meters with 3 stages, in deep wells 30 or more stages. Location for well points inside the excavated area, but for deep wells outside the excavated area. Installations for well points precedes along with excavations installed by jetting or hammering. And for deep wells, installation similar to that for tube wells. One well take few days or weeks to install. Cost, based on the cost, for well points relatively economical down to 15 meter depths, but for deep wells economical beyond 15 meter depths. So these are the comparison for well points and deep wells. Okay. In water, to reduce the quantity of seepage water, the seepage pressure and the dependence of excavation rate on seepage rate, relatively impervious seep piles are driven along the periphery of the working area to the predetermined depth. The excavation is then made and the water is pumped out from the excavation sites of the seed pile walls. Deep filter wells are often used in locations where the water table is deep for lowering the water table or for controlling artesian pressures in the bearing stratum below the excavations, as shown in above figures. Initially, a few wells may be installed, and if they are found insufficient to control, additional wells may be installed. This flexibility is an advantage of these methods. Well points are smaller diameter wells with one or more sections at the bottom slotted or screens. These sections act as filters. The riser pipes are connected to header pipes and water is discharged through discharge lines to a sufficient distance from the working area. Sometimes an additional filter cover of sand is placed around the slotted or screen sections. A well point can lower the water table beyond 4.5 meter in one stage, and if the project requires lowering water tables beyond 4.5 meter, 2 or more stages of well points should be used. Well points are suitable when the submergence available for a well screen is small, that is, impervious layer is close to the bottom of the cut. Okay, so these are the explanations based on well point systems and deep well system, how water table is lowered. Okay, next method is electro osmosis methods. So this is also one more important methods, that is electro osmosis methods to lowering the waters, means dewatering methods. Okay, here this is sloped embankments of excavated area, and this is well points. Okay, this is cathodes, well connected pumping systems, and this is anodes, two perforated tubes. This is, and this third one is original water tables. This is original water tables, and this is steel rods, that is called anodes. So the steel rods, and these are the flow lines. So these are the flow lines. Okay, so during the construction site, water is more dangerous to excavate below the foundations. So to increase the speed of the construction and to minimize the labor work to remove the water, so this electro osmosis method is most important to dewater. Okay, for soils with very low permeability, as in silty soil, instead of gravity drainage, the method's electro osmosis method is more suitable. A line of metal well points serving as cathodes and another line of rods acting as anodes are installed. Okay, as shown in above figures. When electric current is passed through soil having towards the cathode and collect in the wells. When electric current is passed through soils having towards the cathode and collect in the wells, this water is then pumped out. This water is then pumped out. Although the amount of water collected by this method is quite small, its influences on the soil mass are substantial. Due to the removal of water the direction of flow of water is opposite to direction due to the hydraulic gradients, and the effect on soil is twofold. So here hydraulic gradient means it is the ratio of the head of the water to the length of the distance, h by L. Okay, the silt with reduced moisture contents gain in strength, and the soil mass is relieved after seepage pressure, contributing towards the activating force. Okay, here the silt means silty soils. The silt with the reduced moisture contents gain in strength, and the soil mass is relieved of seepage pressure. Soil mass is relieved of seepage pressure, contributing towards the activating force. So this is the explanations with respect to cathode and anode concepts to remove the excess waters from the excavated site to lowering the water tables. This electro osmosis method is also most important. Based on this electro osmosis method, the rate of flow to a cathode well point can be estimated using a modification of Dorsi law as follows. All of you know what do you mean by Dorsi law. Okay, so in Geotech 1 we have already studied Dorsi's law. Same concept here is given by analytical equations, that is Q equal to KIA. But here just it's simplified, Q equal to KE into IA into A. This is given equation 1 for reference, where Q is flow of waters, that is flow rate in cubic meter per second. K is electro-osmotic coefficient of permeability used on voltage 1 into 10 raised to minus 9 to 7 into 10 raised to minus 9 meter per second. IC is nothing but a electrical potential gradient, volt per meters, and A is cross sectional area in meter square. The assumption of power varies from 1 to 10 kilowatt per cubic meter of stabilized soils. For stabilized soil, the assumptions of power varies from 1 to 10 kilowatt per cubic meter of stabilized soils. So based on electrical osmosis method, that Dorsi's concept is applied here to know the flow of waters in terms of flow rates in cubic meter per seconds. Conclusions. Based on the dewaterings and electro osmosis methods concepts, the main conclusions is, in all the above methods of lowering, so we have seen different methods for lowering of groundwaters. The increase in strength is somewhat indirect, as the strength increase is due to an increase in the effective stress or due to a decrease in moisture content affected by the lowering of water tables. So this is the main conclusions seen from all the above methods, that is strength is increased as well as effective stress, and reduces moisture contents. If the moisture content is reduced, strength is increased, If the strength is increased, durability is increased. Durability is increased means that strength of the soil material is increased by lowering the water table. So this is the main conclusions from the drainage dewatering concepts. And these are the references are referred by different authors with different textbooks to prepare the session 8s. Okay, and some IS standards codes is also referred. Okay, thank you one and all. Next class I will be continue.